OCR GCSE Maths 9-1 paper 6 from the November 2018 papers, and this paper is a calculator paper. So let's begin now with question 1. For question 1, what we have over here is a scatter diagram, and over here we have two judges who each award scores out of 30, and this scatter diagram shows the scores awarded to the first 10 dancers. And what we have to do for part A is, we have the scores given for the next two dancers. We have to plot their scores on a scatter diagram. So 21, 18, that's the first thing we have to plot. So 21, 18, that's here. Okay. And we have 7, 8. So 7, 8, that would be over here. Okay. So that's quite straightforward. And now for part B, dancers who are awarded a score of more than 20 by both judges receive a medal. For the 12 dancers, express the ratio of medal winners to non-medal winners in its simplest form. Well, we want a score of more than 20 by both judges. So if we go back to the scatter diagram, more than 20 for both judges, if we draw a threshold, we want everything beyond here. Okay, we want everything beyond this line over here and everything beyond this line over here. Okay, so what we see over here then is that there are 1, 2, 3. There's 3 dancers who receive a medal, so let's write that down. So those who receive a medal by both judges, there's 3 of them. So awarded a medal, there's 3 dancers. Okay, and therefore the number of non-medal dancers we have, well, there's 12 people altogether. Take away the 3, that turns out to be 9. So therefore the ratio of medal to non-medal, so medal to non-medal, that would be 3 to 9. You can simplify to 1 to 3. Okay, so we have 1 to 3. And now for part C, this chart shows the types of dance performed by the 12 dancers. 3 performed a street dance, 8 performed a jazz dance, and 1 performed a tap dance. Why is this diagram misleading? Well, it's basically in 3D, so the diagram's tilted because it's seen from an angle. So it's tilted. From an angle. So that's why it's misleading. Okay, so that's question number 1 done. Okay. What we have for question 2, we have the police who record the speed of vehicles passing a speed checkpoint. The speeds are recorded in the table below. So what we have over here, we have S, which is the speed in miles per hour, and then we have the number of vehicles. What we have to do for part A is find an estimate for the mean. Okay, so the first thing we need to do, we need to find the midpoints of each of the intervals, and after this we need to multiply the frequencies by the midpoints. Midpoint of 0 and 20, that's 10. Midpoint of 20 and 40, that's 30. Midpoint of 40 and 50, that's 45. Midpoint of 50 and 60, that's 55. Midpoint of 60 and 80, that's 70. 5 times by 10, that's 50. 8 times by 30, that's 240. 37 times by 45, let's do this on the calculator. 37 times by 45, we get 1665. So we have 1665. 47 times by 55, 47 times 55, we get 2585. So we have 2585, and 3 times by 70, that's 210. So now to work out the mean would be given by the sum of the frequencies times by the midpoint divided by the sum of the frequencies. So adding all the frequencies times by the midpoints, we have 50 plus 240 plus 1665 plus 25 plus 210 divided by the sum of the frequencies. We have 5, 8, 37, 47 and 3. So on the top we get a total of 4,750. On the bottom we get a total of 10, and dividing these quantities by each other we get 47.5 miles per hour, which is our final answer. And now for part B, we have to explain why it is not to use the information from this table to calculate the exact value of the mean speed. Well, over here we had intervals, so the speed was recorded in intervals. So why is it not possible to calculate the exact value of the mean speed? Well, the exact speeds for each vehicle is not recorded. So the exact speed of each vehicle is not recorded. Okay, that's quite straightforward. So now for the next question. A newborn baby has an approximate mass of 3.5 kilograms. A human cell has an approximate mass of 2.7 times 10 to the minus 11 grams. We have to use these values to estimate the number of human cells in a newborn baby. Give your answer in standard form, correct to 2 significant figures. Okay, so to do this question, first of all, you will notice over here that we have kilograms and grams. So what we need to do first of all is make sure that we have the same units. So what we need to do, we need to convert from the kilograms to the grams. Kilograms to grams we times by 1,000. Grams to kilograms we divide by 1,000. And so it's easiest if we convert the 3.5 kilograms into grams. We do this by multiplying by 1,000. 3.5 times 1,000, that's 3,500. So we have 3,500 grams. And so therefore, if a human cell has this mass and a baby has this mass, we need to figure out how many human cells go into a baby. So we figure out how many of this number goes into this number. So we have over here 3,500 divided by 2.7 times 10 to the minus 11. And working this out, we have 3,000 over 2.7 times the minus 11. And working this out, we of 1.296 etc. times 10 to the times 10 to the 14. Okay, so to 2 significant figures we have 1.3. So we have 1.3 times 10 to the 14 cells. Okay, so for question number 4, we have to use these symbols over here to complete the statement. If x equals 4.7 truncated to 1 decimal place, then we have to complete this interval over here. So to do this question, what we have to do over here, well, if we have 4.7 etc., no matter what number comes after this digit 7 over here, once we truncate this to 1 decimal place, we'll get 4.7 as we require. So 4.7 etc. is equal to 4.7 truncated to 1 decimal place. So x can either be 4.7 or anything that's less than 4.8. So as long as x is in between 4.7 and 4.8, including the 4.7, then once we truncate x to 1 decimal place, of course we'd get 4.7. Okay, so now for the next question, question 5. This part shows part of a village, and Neil knows that Parker Street is 180 meters long in real life, and Neil measures the map. He says Parker Street is 3.5 centimeters long, High Street is 11.2 centimeters long. Therefore, I calculate that High Street is 576 meters long in real life. Use Neil's figures to show that his answer to his calculation is correct. Well, we have our essentially what we have over here, we have on the map we have 3.5 centimeters, and in real life we have 180 meters. From this we can find out what 1 centimeter is. So 1 centimeter is equal to 180 divided by 3.5. So what we have to do over here is divide both sides by 3.5. And doing so, 180 divided by 3.5, that's 360 over 7. So we have 360 over 7 meters. So 1 centimeter represents 360 over 7 meters. We want to find out how long High Street is. High Street on the map is 11.2 centimeters. So we have 11.2 centimeters. So what we have to do over here then is multiply the both sides by 2. And doing so, 7 multiplied by 11.2, we get a value of 576. So over here we have 576 meters, which is what we wanted to show. That's done. For part B, Jodie measures the same map. She says, I think Parker Street is longer than Neil's measurement of 3.5 centimeters. Therefore, High Street must be longer than 576 meters in real life. Well, if the length on the map is more than 3.5 centimeters, so for example over here, if it's 4 centimeters on the map, then what we have over here, we have 4 centimeters, which represents 1 centimeter would represent 45 meters, and therefore 11.2 from, well, as we did before. One times by 11.2 gives 11. So we multiply this side by 11.2. So 45 times by 11.2, that would be 504. And we see that this 504 meters, this is of course less than the 576 meters which Neil calculated. Okay. And therefore we can conclude, well, she's saying that the road must be longer than this 576. We found that it's shorter, so therefore she's incorrect. And now for part C. On another map, Parker Street is 2.4 centimeters long. We have to express the scale of this map in the form 1 to n. Well, over here we have 2.4 centimeters, which represents 180 meters. We want to express this in the form 1 centimeter to a certain number of meters. And to do this, 180 divided by 2.4, we get 75. So we get 75 meters here. So let's just write down what we did. We divided by 2.4. And what we have to do in this question is essentially, we need to now convert the centimeters into meters. Now to go from centimeters to meters, we divide by 100, and meters to centimeters we times by 100. So to convert this 75 meters into centimeters, we have 75 multiplied by 100, which is 7,500 centimeters. So therefore, we have 7,500 centimeters. Okay, so we have 1 to 7,500 as our final answer. Okay, so now that that's questions done, let's move on to the next question. For question 6, in a box of mixed nuts, the total number of almonds, cashews and peanuts is 1025. The ratio of almonds to cashew nuts is 1 to 3. The ratio of cashews to peanuts is 5 to 7. We have to calculate the number of cashews in the box. Well, we have the ratio A to C being 1 to 3. And we have the ratio C to P being in the ratio 5 to 7. And if we get these C's to be the same, we can from this express the ratio A to C to P. So first of all, the lowest common multiple of 3 and 5, that's 15. Now to go from the 3 to the 15, we multiply by 5. 1 times by 5, that's 5. To go from the 5 to the 15, we multiply by 3. 7 times by 3, that's 21. So the ratio A to C to P is 5 to 15 to 21. Now we have this many essentially nuts, if you want to call them. So we can find out the total number of parts. The total number of parts is equal to 5 plus the 15, 21. We'd find this number to be 41. Okay. And so what we can do over here now, we can find out how much we have per part. 1025 divided by this 41 tells us we have 25 per part. Now for cashews we have 15 of them. So for the cashews we have 15 multiplied by 25, which is 375. So we have 375 as our final answer. Okay, so now for the next question. what we have over here is that the probability that any postcard posted in Portugal on Monday is delivered to the UK within a week is 0.62, and the probability that any podcast posted in Portugal on Friday is delivered to the UK within a week is 1. Now in this question, Anna is on holiday in Portugal and she posts 15 postcards to the UK on Monday. How many of her postcards can she expect to be delivered within a week? Now, the key to notice over here is that we're considering Monday. And we know that the probability that it's delivered within a week on Monday is 0.62 in postcards. Assuming that each post is independent, the expected number of postcards is 15 times by 0.62. You would find this value to be 9.3. And therefore we have 9 postcards which we expect to be delivered within a week. Now for part B, Sergio is in Portugal and he posts one postcard to the UK on Monday and he posts another card to the UK on Friday. We have to complete the probability tree to show the possible outcomes for the postcard. Well, on Monday we have over here 0.62 that is delivered within a week. Remember, probability adds up to 1, so 1 minus the 0.62, that's 0.38. Now on Friday, the probability that it's delivered within a week is 0.41. So what we have over here is 0.41 here and here, and therefore 1 minus 0.41, that's 0.59. So we have 0.59 here, 0.59 here. And now for the next part, we have to calculate the probability that only one of Sergio's postcards is delivered within a week. Well, we have over here, we have this multiplied by this. So we have 0.62 multiplied by, or we could have it not being delivered and then it being delivered. So we have to add on 0.38 multiplied by 0.41, and working this out, if times 0.59 or 0.38 times 0.41. I'm working this out, we have 0.5216. Okay, so we have 0.5216. Okay, so now that question's done. What we have over here for question number 8 is the speed of a cyclist during the first 20 seconds of a journey. For the first part, we have to find the acceleration for the first 4 seconds. Now, the acceleration we can find from a speed time graph by finding the gradient. We're considering the first 4 seconds, so the gradient of this line, change in y over change in x, that would be 8 over 4, which is 2. So we have 2 meters per second squared. And between 4 and 14 seconds, we see that we have a horizontal line. So we have dy over dx equaling 0, or if you want to think change in y over change in x. And therefore we have 0 acceleration. And now for part B, we have to work out the distance travelled during the first 20 seconds. Well, we have 3 segments over here. We have our first segment. If we split this entire area, now I should probably point that out first. The area underneath the speed time graph is equal to the total distance. And what we see over here, we have 3 regions. We have region 1, region 2, and region 3. Now for region 1, over here, we can find out that area. That is equal to, well, that's a triangle, So we have a half times by the base, which is 4, times by the height, which is 8. So that's that particular region. For the second region, we have a rectangle. We have a base of 10. We have a height of 8. And for this last region, we have a trapezium. So we have a half times by the two parallel sides. Here we have 10. Sorry, we have 8 and 10 over here. So we have 8 plus 10. And we have a height over here of 6. So now working this out, we have 2 times by 8, which is 16, plus 80, and over here we have 3 times by 3 times by 18, which is 54. So in total we have 150 meters. So we have 150 meters. Question 9. We have these graphs which show different relationships between the variables x and y, and we have to identify the graph which shows the following. So when y is directly proportional to x, we want a straight line which goes through the origin. That would be graph A. And if we want to find out when y is inversely proportional to x, well, that's the graph of y equals 1 over x. Of course, here we have y equals x, and that would be graph C. And now for question 10, we have to sketch a graph which shows that y is directly proportional to x squared. Now, of course, we only consider positive values of x, so we draw the graph of y equals x squared, where x is greater than 0. So we have something like this. Question 11. A regular polygon has n sides, and the polygon's interior angle is 5 times the size of its exterior angle. We have to find n. The first thing to notice, if we say that the exterior angle is x, then the interior angle would be 5x. Okay? 5x degrees. So with this information, if we can find out the exterior angle, then we can use the fact that the number of sides n equals 360 over the exterior angle. We can use this formula to find out the number of sides. So with that being said, ow, that hurt. It's gone out of focus, bear with me. What we have over here, well, we should know, one of the facts we should know is that, it's gone off focus again, that's annoying. Just bear with me whilst I just focus this camera. We should know that the, what was I going to say, the interior angle plus the exterior angle is equal to 180. So we have our interior angle 5x plus our exterior angle x. This is equal to 180. We see that we have 6x, which is 180. X is equal to 30. Now this x, of course, corresponds to our exterior angle. So therefore the number of sides n is equal to 360 over 30. You'd find this to be 12. So therefore n is equal to 12. So now for the next question. In the diagram, the square and the trapezium share a common side of length x centimeters, and we have to work out and the area of the square is equal to the area of the trapezium, we have to work out x. Okay, now to work out the area of a square, the area of this square, that would be x squared. And we know that this is equal to the area of the trapezium. The area of the trapezium, well, we have a half times by the two parallel sides, x and 10, multiplied by the height, which is 6. So let's just simplify all this. What we have over here is x squared. A half times by 6, that's 3. So we have 3 lots of x plus 10. So we have x squared plus x squared equals 3x plus 30. What we do now is take everything over to one side. The other side must equal 0. So we have x squared minus 3x minus 30 equals 0. We wish to solve this. We can use the quadratic formula if we remind ourselves of what the quadratic formula is. Well, we'll write it down here. Well, actually, we'll write it down here. For the quadratic formula, when solving ax squared plus bx plus c equals 0, x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. So using this information, we have x equals minus b, so we have minus 3 plus minus the square root of b squared, so we have minus 3 squared minus 4ac over 2a. So working this out, we come out with 3 plus or minus, well, we have 9 plus 120 over 2. So we have 3 plus minus 129 over 2. So we have x equals, now we have two possibilities. We have 3 plus root 129 divided by 2. We get an answer of 7. Or we end up with, well, if we have 3 minus root 129 divided by 2, we have minus 4.17. We see that this length is impossible, and therefore we can conclude our only value of x, because remember we're dealing with lengths over here, so we must have positive solutions. We have 7.17. So we have 7.17. Okay. So the next question. Question 13, we have the shape below, which is formed of two semicircles and a straight line. Of the large semicircle is 8 centimeters, so therefore the diameter of the large is equal to 16. And the radius of the small semicircle is t centimeters, so d small is equal to 2t. Alright, the diameter is twice the radius. We have to find an expression in terms of t for the exact perimeter of the shaded shape. Well, what we have for the perimeter, we have the big outer semicircle, so we have pi lots of 16 over 2. Okay. And what we also have is 16 minus 2 what we know over here is that the diameter of the big semicircle is 16, and for the little circle we have 2t over here. So this bit and this bit, so this bit and this bit over here would give us the 16 minus the 2t. And then we have the inner bit. The inner bit would be given by pi lots of 2t over 2. And the reason I'm dividing by 2 over here is because we have half of the circle. Okay. So we have 8 pi plus 16. And in terms of t's, we have t pi minus 2t. Okay, so we have 8 pi plus 16 plus pi t minus 2t. Okay, just bear with me. Now for question 14, without using a calculator, we have to show that 0.19 recurring can be written in the form 19 over 99. Well, that's easy. Well, if we say that x is equal to 0.191919, etc., because we have 2 digits recurring, multiplying by 100, 100x is equal to 19.191919. Subtracting these, 99x is equal to 19, x is equal to 19 over 99. For part B, explain how 19 over 99 equals 0.19 recurring can be used to find 19 over 990 as a decimal and write down its value. Well, essentially to go from here to here, we divide by 10. So if we divide by 10, what we have to do is divide this value by 10. So we have 0.019 recurring. Now for question number 9, we have to use the formula xn plus 1 equals xn cubed over 30 plus 2, with x1 equaling 2 to calculate the values of x2 and x3. Round your answers correct to 4 decimal places. Well, if we have x equals 2, the value of x2 is equal to x1 cubed over 30 plus 2. So we have 2 cubed over 30 plus 2. I'm working this out. If we substitute 2 into our calculator, and then if we have 2 cubed over 30 and then plus 2, it turns out we get this value. So to 4 decimal places, we have 2.6667, and the value of x3 is equal to x over 30 plus 2. So we have 2.66 cubed over 30 plus 2. I'm working this out. We have this value over here, which decimal places we have 2.3881. Okay. Now for question number 16, a £1 coin weighs 8.75 grams to the nearest 0.01 grams. Metul weighs the contents of a large bag of £1 coins. The coins weigh 2.63 kilograms, correct to the nearest 10 grams. And he says that I am sure that the bag contains exactly 300 pounds because, using bounds, 2625 divided by 8.755 equals 299.8 to 1 decimal place. Show that me tool may not be correct. Well, first of all, what we have to do over here again, we notice that we have kilograms here and grams here, so we need to first of all convert the units. So we need to go from kilograms to grams. We times by 1000. Here we divide by 1000. So here we have 2.63 times 1000, which is 264 grams. Okay, now for a single coin, for a single £1 coin, the upper bound is equal to 8.745 and the lower bound is equal to 8.755. And with all the coins in the bag, the upper bound, sorry, this is upper and this is lower bound. The lower bound is equal to 2625 and the upper bound is equal to 2635. So if we want to find out how many coins there are in the bag, using bounds, we have 2635 over the lower bound, so we have 2635 over 8.745. And now the reason I'm doing this, because over here what they've done is they've done over here the lower bound divided by the upper bound. So what we're doing over here is the upper bound divided by the lower bound. Okay, so we have 265 divided by 8.745. I'm working this out, we get 301.3, etc. So we have 301.32 to 2 decimal places. So it could contain more than 300 pounds. So could contain more than the 301. Well, it could contain more than 300 pounds. Now for question number 17, what we have to do in this question is find the exact coordinates of the two intersections of the line y equals 2x and the circle x squared plus y squared equals 30. Substituting this into this, what we have over here is x squared plus 2x all squared, and this is of course equal to 30. So we have x squared plus 4x squared equals 30. 5x squared is equal to 30. X squared is equal to 6. X is equal to plus or minus root 6. And if x is equal to plus or minus root 6, substituting this into y equals 2x, we can see that y is equal to plus minus value. So we have plus minus 2 root 6 for the y coordinates. So we have minus root 6 minus 2 root 6, and then here we have root 6 2 root 6. Question number 18. We have to sketch the graph of y equals cos x plus 1 between 0 and 720. Noticing cos x is periodic, so cos x is periodic, so it repeats every 360 degrees. So with that information, what we can first of all do, if I draw the graph of y equals cos x, we have something which looks like this between 0 and 360. And repeating this, we have something like that. So this is y equals cos x. And what we're doing over here, we're adding 1 to each of these y values. So we need to shift this graph up by 1 value. And doing so, I will do my best to do this. We have something like that. So this is y equals cos x plus 1. And now for part B, we have to explain why the equation cos x plus 1 equals 2.7 has no solutions. Well, solving this, we have cos x equals 1.7, and this has no solutions. And that's because cos x is in between minus 1 and 1, and we saw that in the pencil over here. Its values go from minus 1 to 1, and anything beyond this we can't solve. So that's that question done. For the next question, question number 19, we have a triangle over here. We have AB, which is 9 centimeters, AC, which is 10 centimeters, BC is greater than 5 centimeters, the angle BCA is 60 degrees, and the angle ABC is less than 90 degrees. With this information, we have to calculate the area of the triangle. We can first of all use the sine rule, reminding ourselves of what the sine rule is. We have sine A over A equals sine B over B equals sine C over C. So with this information, we can find out this angle B over here, because we have an angle, a length opposite it. We're finding this angle, we've been given the length opposite it. So we have the sine of B, which is equal to, sine B over 10 equals sine C, so we have sine 60 over 9. So sine B is equal to 10 sine 60 over 9. Working this out, what we have over here is 10 times by the sine of 60, and dividing this by 9, we have 0.96, etc. And therefore the angle B is equal to the inverse sine of this. So working this out, so the inverse sine of this, that's 74.2, etc. So what we have over here then is 74.2, etc. And therefore this missing angle A, the angle A is equal to 180 minus the 60 degrees minus the 74.2, etc. You'd find we get 45.7, etc. degrees. So we have over here 45.7, etc. degrees. So with this information, we can now use a different formula to find out the area. That is, the area equals a half BC sine A. So we want an angle and 2 lengths in between that angle. So therefore the area over here, we have a half times by 9 times by 10 times the sine of this 45.7, etc. I'm working this out. So what we need to do, 180 minus 6, this. So then we have 45 sine of this, which is 32.2, etc. So we have 32.2, etc. centimeters squared. Question number 20. B is a vector, and given that B plus 5 over 2 is parallel to 2, 1. We have to find two possible answers for B. Well, if it's parallel, then this result must equal, well, what we're saying over here is that B, the vector B plus 5, 2 is equal to some multiple m of 2, 1. Okay? Now, we can choose any value for m. For example, when m is equal to 1, what we have over here is the vector B plus 5, 2 equals 2, 1. What we can therefore see from here is if we call this x and y, we have xy plus 5, 2 equals 2, 1. We can therefore see xy over here, 2 take away 5, that is minus 3. 1 take away 2, that's minus 1. So we have one possible solution, minus 3, minus 1. And the second solution, for example, when m is equal to 2. When m is equal to 2, we have b plus 5, 2 equals 2 lots of 2, 1. So we have the vector b plus 5, 2 equals 4, 2. Okay, so we have over here xy plus 5, 2 equals 4, 2. So we can see from here xy is equal to 4 take away 5, that's minus 1, 2 take away 2, that's 0. So we could have another solution of minus 1, 0. The important thing to notice in this question, it doesn't matter what m is, the key is to get this bit over here. Now for part B. Given that m lots of, where's my block pen? 4, 1 plus n lots of 5, 2 is equal to 12, 6. We have to find the values of m and n. So expanding this out, we have 4m m plus 5n 2n equals 12, 6. Comparing the I components, we have over here 4m plus 5n equals 12, and on the bottom we have m plus 2n equals 6. We'll call this equation 1, this equation 2. We have simultaneous equations. Multiplying this one by 1 and this one by 4, we have 4m plus 5n equals 12, and 4m plus 8n equals 24. Subtracting these, we see that 3n, because the 4's cancel, and 8 minus 5, that's 3. 3n is equal to 24 minus 12, which is 12. N is equal to 4. And when n is equal to 4, we can find out the corresponding m coordinates. So substituting this into here, we have m plus 2 lots of 4 equals 6. M plus 8 equals 6. M is equal to minus 2. So we have minus 2, 4 as our solutions. And now for question 21, we have to show that 5x over x plus 5 plus 25 over x minus 7 minus 300 over x plus 5 lots of x minus 7 simplifies to an integer. Well, to do this question, let's first of all focus this. To do this question, what we have over here to begin with, let's put everything over a common denominator. So what we do over here is we cross multiply essentially. So we multiply the 5x by the x minus 7. And then we have 25 lots of x plus 5 over x plus 5 lots of x minus 7, and then we subtract off this 300 over x plus 5 x minus 7. And because we have this common denominator of x plus 5 lots of x minus 7, combining these, we have 5x lots of x minus 7 plus 25 lots of x plus 5 minus 300 over x plus 5 lots of x minus 7, and expanding and simplifying the top 5x lots of x, that's 5x squared. 5x times by minus 7, that's minus 35x. 25 times by x, that's 25x. 25 times by 5, that's 125. Minus the 300. On the bottom, we have x plus 5, x minus 7. So on the top, we have 5x squared minus 35x plus 25x, that's 10x. And 125 minus 300. Sorry, here we have minus 10. That's 175. On the bottom, 5 lots of x minus 7. And on the top, what you'll notice, we can factorize a 5 from each term. So we have 5 lots of x squared minus 2x minus 35. On the bottom, we have x plus 5 lots of x minus 7. And the x squared plus 2x minus 2x minus 35. We have x plus 5 lots of x minus 7. On the bottom, we still have this x plus 5 x minus 7, and happily for us, the x plus 5's cancel and the x minus 7's cancel. So we are left with 5, which is an integer. So that concludes the end of the paper. Don't forget to like, share and subscribe, and any questions, please feel free to comment them in the comment section below. I'll see you guys in the next video.